Hi everyone, welcome to our talk on AI ethics and regulation for a trustworthy AI ecosystem. So I'm Oonagh, I'm a second year electronic engineering student at the University of Nottingham. Just a quick reminder that we are recording this so you can watch it back on the East Midlands YouTube channel. Before we get started, just point out there is a Q&A button, so if you do wish to ask any questions, please feel free to put them there throughout the chat, where our speaker will be able to answer them at the end. So if I hand you over to Ansgar now, and he'll be able to talk more about AI ethics and regulation for you.
Sure, great, thank you. Just a brief check, the talk itself is supposed to be how long exactly?
Roughly 50 minutes.
50 minutes, okay, sure, good. So welcome everyone. My name is Ansgar Koene. I am a senior research fellow at the Horizon Digital Economy Research Institute at the University of Nottingham. I am also, and actually primarily, now the global AI ethics and regulatory leader at EY. So I spend most of my time at EY at the moment and part-time at Horizon. So as my title indicates, I focus primarily on questions around the way in which AI is being used, the ethical issues that arise from it, as well as the regulatory developments that are coming out, things like the European Union's AI Act that is under development, but also things such as the UK's national AI strategy and related developments. And the way in which these kinds of regulations have an impact on the way in which these kinds of AI applications are being used both in industry and in the public sector kinds of uses. So today I wanted to speak about AI ethics and regulation for a trustworthy AI ecosystem, basically providing a bit of an overview as to why we are concerned about ethics when it comes to AI, what are the actual issues that are the cause of this, and how are these things being addressed through the policy and regulatory developments. So first off, algorithms, algorithmic decision-making, AI, call it what you will, basically the use of automated systems for guiding the kinds of information we receive, deciding the outcomes of certain decision processes, driving recommender systems, etc., are something that is already increasingly being used for applications that have real-world implications to people, and at the same time are frequently showing up in the news with news stories such as the recommender systems of Facebook driving bad content to people, failure to be able to identify fake news, bias in the way in which people receive credit scores, and many other ways. So there's a plethora of news items indicating problems with the use of AI systems, which is not really to be surprised at when it comes to deploying a new type of technology at quite such a large scale. However, these news stories, even if sometimes the titles are a bit exaggerated, do point to real problems that require being taken seriously and require that frameworks are being put in place to address them. So why is AI raising questions about ethics as opposed to merely questions around safety or questions around the quality of performance of the systems? Why ethics when it comes to AI? So one element I would say has to do simply with the anthropomorphic terminology that we use when it comes to AI. For starters, artificial intelligence, automated decision-making, and machine learning, intelligence, decision-making, learning, all of these suggest a kind of human-like type of quality of true understanding of the process of what it is dealing with. And frankly, they somewhat exaggerate what this technology can actually do, but it raises a kind of picture in people's minds of a system that should have similar kinds of issues, similar questions around does it have the correct intent, or what are the sort of ability to hold responsibility, and so that raises the question sort of an ethics, of a knowing of what is good in this kind of space. Another big aspect is the system complexity. We are dealing with systems. I mean, why do we use AI systems? Because we are trying to ingest a very complicated set of data and identify patterns within that data in order to be able to drive better decisions, to optimize processes. So system complexity, but dealing with a complex system inherently means we're also dealing with a system that is difficult to understand. It's difficult to, at a human level, know what is the decision-making process that has been going on. Is this the right kind of thing? And so this kind of black box nature of it raises questions about agency, and that then also raises sort of issues around, is it ethical to deploy this kind of a system if we don't exactly know what it is? An AI-based, and the third point is that AI is based on statistical correlations. It is automating decisions without an actual understanding. It is dealing with patterns. And so especially if we're looking at rolling out AI-based, especially machine learning-based approaches in spaces such as criminal justice, or even in things such as social justice, the evaluation of who gets access to benefits, for instance. Is it legitimate to be using a statistical approach in that space? Or if we say that, for instance, criminal justice, every defendant should be assessed based on the evidence of their particular case, not based on an average statistics of people. So is the fundamental underlying basis of how these systems work actually compatible with what we consider to be the proper way of assessing a particular case? And then there is a sort of additional element that potentially we might argue is sort of just a matter of historical developments, but that is a lot of the AI technologies are being developed and certainly being deployed by companies that are sort of the big tech that have also been commodifying personal data, that have been in the news already a lot prior to the introduction of AI in the debate around data privacy, and as such, by certain parties at least, are being considered as somewhat suspect when it comes to their the morality of how they're using AI systems. And so that also brings ethics into the discussion space. If we're thinking about trustworthiness of AI systems, it is important to step back and clarify that trustworthiness consists of two parts. One part is the ability to deliver. If I'm engaging with somebody and they promise to do X, do I trust that even if they have the best intentions in the world, they are actually able to fulfill that promise? Are they simply capable of delivering? So that's one part. But the other part is the value alignment. If the person promises to do X, is that their true intention, or are they actually intending something else? Are their motivations aligned with me? So that's a different element. So the ability part largely aligns with questions to do with accuracy, precision, robustness of the automated system, whereas the value alignment part largely connects to questions around transparency, explainability, privacy as well. Are you going to use my data for what you have said you're going to use it for? Or are you going to use it for something else? accountability, those kinds of dimensions in the AI ethics discussion largely connect to the value alignment kinds of issues. And bias, in a certain sense, lies between these, because bias can arise both due to simply a failure of the system to properly deliver, a failure to be able to produce accurate results for a certain population, or bias can arise due to the way in which the system is being optimized, the optimization target, or the way in which it is being deployed, having actually intentions behind it that are somewhat contrary to perhaps a fair distribution. Examples of this being the deployment of AI systems for things like assessing people's access to medical health, healthcare, where the underlying optimization target that was being built into it was to reduce public expenditure. So the system was built to reduce the amount of money that would be spent, and so therefore it would always be targeting to not give people access to the healthcare if at all possible. So ability and value alignment are both two elements that come into the trustworthiness discussion. The other question is, and that also connects to this previous one, is are we talking about the tool, the actual capabilities of the AI system, or are we talking about the intended use? And actually, if we consider a lot of the issues that people are concerned about when they're talking about AI ethics, often this has to do with the intended use. So for instance, if we're talking about the ethics of face recognition, the deployment of face recognition, to a large extent, people are concerned about face recognition, not so much because of the quality of the ability of the algorithms to distinguish certain faces, but they are concerned simply because they don't like the movement towards a surveillance society, and really whether or not this is being done by AI or whether it were being done by a huge number of humans watching the cameras wouldn't really matter that much as far as their concerns are come into play. Really what they object to is the face recognition as such being deployed. So that is more a societal concern, which, if we're talking about who has a responsibility to addressing those concerns, lies more with the policymakers, or in the industry case, for instance, the C-suite. Whereas if the issue is with the technology itself, if we are objecting to the use of a particular AI system because its performance is such that it is better at serving certain people than it is at serving other people, for instance, as in the case of face recognition, when face recognition algorithms perform very well for white male subjects, but very poorly for Black females. If the concern is just around that disparity in performance, then we're talking about a technical issue where engineers and data scientists might be the more directly involved party for trying to resolve the issue. So one example, for instance, in that latter case is the gender shades study by Joy Bulwimi and Timnit Gebru from 2018, where they did a review of the different face recognition algorithms that are commercially available, and looked at their performance and across different races and genders. And they then they calibrated this or compared this to the impact that the different data sets, the training data sets, had on this performance. And one thing that they've pointed out, especially in this study, is that the initial training data sets were heavily skewed. As a result of that, the performance, so the technical capability of the AI systems, was quite biased towards white males being dealt with more effectively. But if they offered up a test data set that was calibrated to be balanced across genders and races, and retrained and basically challenged the companies to retrain their system based on this, they actually showed that the final systems performed not just better for the minority group that previously hadn't been well served, but even performed better for the majority group, because the system internally had been challenged to identify more types of different features, more relevant kinds of features. So indicating that there can actually often be also a connection between reducing this kind of technical bias and improving the general accuracy of systems. A different element, however, which to a certain extent has achieved less prominence in a lot of the sort of public debate around bias in AI systems, is not directly related to the quality of the data sets, but rather to the question about how the optimization targets are set. So that came out really out of a study connected to the sort of following the report on machine bias by ProPublica, where they analyzed the COMPAS system, a system used in the criminal justice in the US for providing judges with a recommendation on the likelihood that a particular defendant would reoffend if released on bail or parole, given early parole. And really what the study showed was that based on the way in which the journalists analyzed the data, and the journalists looked at how the system performed when it made an error. So it looked at false positives and false negatives. The journalists showed that for those cases, false positives and false negatives, the system showed strong racial bias, that it would generally, when it made an error, would assume that white defendants would be less likely to reoffend. And when it made an error, it would assume that Black defendants would be more likely to reoffend than they actually were. Whereas the company that had produced the system claimed that their system is not biased racially, because they had focused on making sure that it would get a good, correct answer at equal rates for Black and white defendants. So they were focusing on accuracy as opposed to false positives and false negatives. And subsequent analysis of the data, the underlying statistics of the data, showed that it is actually impossible to make a system that would be unbiased across all different measures of performance. And so what that really highlights is that the question of whether or not a system is biased depends also on the question of what it is that we are optimizing for. And this is not something that can be solved through maths, because mathematically these are simply mutually exclusive. But this is really a social discussion, a societal discussion. What do we as a society consider for this use case, this particular use case of using a system in the criminal justice system? What is the proper system, the proper dimension that you should be optimizing for when it comes to removing or minimizing bias in this kind of a system? Should you be minimizing bias in accuracy, or should you be minimizing the kind of bias that you get in the false positive, false negatives? Another dimension, and this is just sort of at a very high level, if we look at the deployment of AI systems, or even the conceiving of using AI systems, is that fundamentally what we are talking about systems that do not have a human experience of the environment. They do not have a complete experiential understanding of what it actually means, this data that is being fed into the systems. The AI system, the only knowledge that the AI system has of the world is the data that it's being fed in with. The only understanding, between quotes, that the system has of how to deal with that data is the categorizations that we are asking it to make. And so it fundamentally, anytime you're going to use an automated system for dealing with a human, really automated, doesn't matter whether it's machine learning or rule-based, any kind of automated system, it will always reduce a complex individual into a kind of binary stereotype, maybe more than two stages, but a simplistic kind of stereotype of the person, as was very much the case in this kind of example where a study where they looked at whether you could use facial images, analysis of facial images to try to identify somebody's sexual orientation, and leaving aside the very many sort of technical flaws within the paper, my point here is that the way the task was set up for the AI system to begin with, stating that every face should be allocated as either being homosexual or heterosexual, is in itself already a simplification of human reality, because the reality is that that sexuality is on a spectrum, it isn't a simple binary. But the point that I'm trying to make is at the more larger level, that any kind of time that you are defining a particular task, you are reducing, simplifying situations. And as you're automating that kind of task, you're reducing the ability to step back and understand, in this particular case, perhaps the way in which the automatic classification is being deployed isn't actually the appropriate one to be used. And finally, on this kind of overview of sort of the triggers and sources of issues that arise, that give rise to the ethical concerns, I want to sort of take this analysis from that was published regarding how by Arvind Narayanan, regarding how the different kind of domains or types of decisions that we're asking from an AI system can actually link it to different levels of trustworthiness. So in this case, what the way he's looking at it is the system being asked to do a judgment on something for which we have a established ground truth? So perceptual kinds of tasks, is computer vision task where you're asking it, is this a cat or is this a dog? Or perceptual tasks such as text or speech recognition. For those kinds of things, we have a clear ground truth. We know this is correct performance or not. We can easily test that. For these kinds of systems, it is possible to basically establish a clear way of defining the system's performing correctly, and therefore deploying it and making a claim that the system is performing correctly makes sense. Then there's a different kind of class of applications, automated judgment. So typical kind of examples of that would be recommender systems, sentiment analysis and spam detection, such kinds of applications. In this kind of case, it is not that easy to indicate for every single instance easily whether performance is correct or not. However, we do have a fairly easy way of collecting a large amount of examples, and from the way in which those examples are generally being judged by humans, for instance, we can come to a consensus of what is correct performance. And so that kind of consensus can then be emulated by the AI system, giving us a sense of, is the system performing correctly? So these kinds of systems, a bit more difficult to judge whether their performance is actually good or not, but still possible to get a kind of baseline against which to judge them. A third category, however, in which is the one that Arvind suggests using sort of the snake oil comparison to, is systems where it is claimed to make grand kind of predictions that are related to things where it is actually very difficult to get at the kind of data that you really want to be assessing. So things like predicting future job success or predicting recidivism and those kinds of things, predictive policing. These are all cases where we don't actually have access to the ground truth that would be able to tell us whether the system is performing correctly or not. In the recidivism case, for instance, we have the problem that for people that we have released on bail, we can see whether or not they reoffend. But for the people that we did not release on bail, we cannot see whether they would have reoffended if we had released them, because this alternate reality doesn't exist. In predictive policing, the systems very much suffer from feedback effects. Because you are expecting crimes to happen in a particular area, you deploy more police there, so you detect more crimes happening. just simply because that is where you are looking. In job predictions, you cannot measure whether or not the person to whom you did not give the job would have been successful at that job because they never got a chance. So it is very difficult to get an actual measure of the performance of the system in this kind of space, because you cannot measure that alternate reality that you would need in order for you to be able to test them. And so any kind of claims to the level of success of those systems are very difficult to evaluate. So coming out of these concerns, what we've seen in an initial kind of phase of discussions has been this kind of general push that we need to establish principles, core principles as to what AI systems need to be able to do, or the governance around the AI systems needs to provide in order for us to be able to say this is an acceptable use of them, and how to evaluate deployment cases, use cases of them. And so many different AI principles have been published by now, more than 100. It started with the Asilomar AI principles back in 2016, 17, I believe. And then sort of the peak of publishing of new ones was around about end of 2018, beginning 2019. Sort of a core one to look at if one is interested in the policy discussions around AI systems is the OECD AI principles, primarily because OECD being already a group of 30-something countries, and then those principles have also been adopted by the G20, and so it has become sort of the reference point for a lot of national governments. And generally, all of the AI principles sort of align pretty much on the similar kind of sets of statements. So if we look at the OECD AI principles, they basically come down to 5 sort of classes. The first one being inclusive growth, sustainable development, and well-being, or we could consider this as do no beneficence approach. Then there's human-centered values and fairness. The system should be there to serve humans. Transparency and explainability, robustness, security and safety, and accountability. And then they provide sort of recommendations for how to start delivering against these in policy making. Building on these AI principles, governments have now started moving forward in their general consultations. So the general sort of development stages when it comes to creating a new policy on technology, but on many other issues as well. And certainly also in AI is this kind of phases of, you start off with fact checking, getting expert consultations to understand what the issues are. So the UK started quite early on this one. For instance, things like the Lords AI Committee back in 2018. But also, for instance, the European Union's high-level expert group would fall within this. Then the next stage is typically, or at least in the AI case, has been the AI principles. So many countries have established those now. Then moving to national strategies, identifying where this particular country sits when it comes to the potential benefits that AI can bring to the country. So for instance, where should investments be being put? Is the country considering itself to be a competitor with the rest of the world to try to compete to be a general leader in AI, or is there a particular subdomain of AI usages that the country wants to take a lead in? Potentially a country isn't intending to be a leader in the development, rather a leader in experimentation around the deployment of them, such as Malta and the UAE are positioning themselves as a kind of sandbox place where you can try out new AI systems. Then the next step is legislative gap analysis. So at the moment, the map actually shows the 53 nations that currently have a national AI strategy published or forthcoming. Out of those, only a very few have already moved on to the actual legislative gap analysis. The UK, with its along with its national AI strategy that was published just a week ago, or is it 1.5 weeks ago now, is sort of moving in that kind of direction. We see, for instance, the Center for Data Ethics and Innovation is looking at an AI assurance roadmap to identify also, is there a need for new regulation in this space? The European Commission has published in April already its proposed AI regulation, and being the first to actually do that. Another leader being Singapore, which has some strong guidance around the use of AI, not yet regulation, but they are strongly leaning in that direction. The US is following somewhat more slowly, and in a sense is hindered in its ability to move in this kind of direction, also by the lack of a federal privacy legislation, but instead is seeing more activity happening at the regional space, but I'll get to that in a couple of slides. So following this legislative gap analysis, there is a movement towards actually proposing new or amended legislation, and that is basically the EU is the first one to move in that direction. And that proposal from the EU is drawing quite a lot of attention also internationally to see what are the responses to this proposal, what are the elements that are being challenged most strongly, or is that kind of direction being sort of well received by people and by industry. So governance frameworks that could, for instance, be could involve regulation for AI systems can be, or digital technologies in general, can come in a number of dimensions. One is market-based solutions, which is basically the we don't need regulation kind of approach, but rather we will let the market sort it out. And this can be either demand side or supply side. So demand side means it is the way in which customers are asking for systems is going to drive systems to becoming better suited, whereas supply side means it is driven by the supplier. And then there's company self-organization and branch self-regulation. So part of that, for instance, also standards development. Co-regulation is when those kinds of standards become monitored by a government or guided by government. And then state intervention is basically the case of actual imposing regulation in this space. I won't go into too much detail, but basically, if we look at what is happening in the digital space to a large extent, be that AI or privacy legislation as well, or monopoly kind of market power issues, what we see is that the market solutions are not working very well, primarily because of network effects that are causing, making it too beneficial for a very few sort of leading companies to be there. Simply by being big, your ability to produce better systems that more effectively operate becomes much easier. And so it becomes very difficult to criticize those systems in a market kind of way. You're not going to move away from the large provider, even if that provider is not dealing with your data in the right kind of way, because its services are simply better quality, better able to provide the accuracy, the ability to deliver outweighs to a certain extent the question about intent and motivation when it comes to these types of technical systems. And the self-regulation space, an interesting element that we've seen there is that at the company level, in the big tech firms, it has actually been driven more from the employees as opposed to from the top down. So things like Google's is not renewing its Project Maven, the participation in the Pentagon drone AI image program, or the withdrawal of face recognition technology for software to police have been driven largely at Amazon, has been driven largely by protests from employees as opposed to the management side. At the branch level, what we do see is that standards development is in full gear now. The ISO and IEC, so the international standards development organizations, are currently working on many standards related to AI that are due to come out in the coming year, more or less, maybe coming 2 years, which will provide a much stronger basis for knowing what is good quality in the sense of ability to deliver, but also quality in the sense of oversight and governance structures for AI systems. And IEEE also providing quite a number of standards. The first number of standards in the ethics space being published now, especially the P7, or this, now it's called the 7000 standard on how to implement ethics in the design of AI systems is an interesting one in that space. State intervention, we've sort of talked about regulation already, but in addition to this kind of deliberative approach, where governments are approaching a technology from that kind of stepwise approach of getting expert knowledge, assessing what is the most effective way of deploying regulation that would balance the ability to innovate with the requirements of safeguarding society. In addition to that approach, there's also a reactive policy development happening. And this is something that we've seen perhaps most clearly when it comes to things like face recognition in the US. As I mentioned, the US does not have a clear AI regulation being developed in that kind of a deliberative approach, but at the state level and at the city level, quite a number of jurisdictions have actually passed legislation already to ban the use of face recognition by the police, or sometimes even more broadly by the public sector, as a result, reactively, as a result of public outcry around the use of AI systems by the police, triggering concerns around racial discrimination specifically. And similar things we've seen in Europe, for instance, as well, with the Dutch court, for instance, ruling on the use of an AI system in assessing potential benefits fraud. And so these are cases where, rather than a sort of assessment of the properties of the system having driven the decision to move with a particular regulatory approach, it is systems that are flawed having been deployed and having triggered harm in people, and there's a sense of a need to respond to that harm, and so you get a rapid deployment of some policy decisions that may not be as finely tuned, but that do more rapidly respond to a particular need in society. And so just to wrap things up, some of the key questions when developing or deploying algorithmic systems in order to try to make sure that you are addressing ethical concerns are to make sure that there's clarity as to who will be affected by the deployed AI system. Do you actually understand the stakeholders that will be having to deal with the ramifications of deploying the AI system? Being clear as to what the decisions and optimization criteria are that you are using. Where are you making decisions when it comes into the development of this system? Such as when you were selecting the data that you're using both for training and for validating the system, how did you decide to do this? Is it simply the easiest to get data, or is there a process in place to make sure that the data is properly representative of those to be impacted stakeholders? How did you choose what definition of fairness is the most appropriate one in the in the way in which you're optimizing your optimization targets? have been defined for the AI system. How have you evaluated that this is the sort of an appropriate domain within which to use an automation of the decision-making process, where you are removing the ability of people to immediately address and get recourse to human oversight potentially, or how have you made sure that that ability for human a human reassessment is still capable in your application space? Then how are these criteria, those criteria for the decisions that you made, how are they justified within the particular application where the system is being used? If you are using certain dimensions of factors for making the assessment of people, for instance, if you are including gender as part of the decision criteria, is that justified within your particular application? Because perhaps this is a medical application where gender is actually relevant to the potential diagnosis, or is this not justified in the particular application? And finally, are these justifications acceptable in the context where the system is being used? So bringing it back to the stakeholders that will be impacted, are your justifications actually going to be acceptable to those particular stakeholders, or is this perhaps not the right place to be using this kind of an automated system? And so that was my quick tour of the issues and the current approaches and the policy debate around AI ethics and regulation. And so now I will start to try and have a look at the Q&A.
Thank you very much, Ansgar, for that talk. Would you prefer if I read out the questions to you?
Sure, if you could.
So we have one question saying, can we define what intelligence is, and even what artificial is in regards to the intelligence? And if not, how do we know if what we're dealing with is an AI when making trustworthy decisions?
Philosophically, this is a very interesting question. We do not have a good definition of intelligence. Artificiality, I would probably say, is easier to define or accept that we have a sense of this is an artificial one or not. However, if we actually look at the way in which the debate around AI deployment and AI policy making is concerned, one of the things that we can note is that having a very specific definition of AI is actually less important. We can see this very clearly, for instance, in the European Union's AI Act. They're using a very broad definition of AI because fundamentally what we're talking about is, are there concerns around the way in which an automated system is operating? And if we are saying this, the application of AI to this particular use case is perhaps not a good way of using it, would it really make a difference if it isn't machine learning and therefore isn't strictly AI, but instead some different kind of software? Would it then suddenly be okay? Usually not. So usually we don't really care in the policy space whether or not something is strictly AI. We are more concerned about, is this something where there's a potential for harm that people need to get protected? And so a more expansive definition of AI is usually used, even though there's a lot of people who from a more technical side will look at it and not feel comfortable with all of this stuff being included in the category of AI.
That's fair enough. Okay, so next question. How do you get a balance or a diverse data set for testing? So when we were talking about the mixture of data regarding AI testing, it might be because the number of subjects may not be available. How can you then deal with that?
So there are some methods for trying to create artificial data to fill in some gaps. There are ways to sort of do oversampling of a particular group. But none of these, of course, are as good as having real data when it comes to these. So one of the elements there is to primarily just to be aware of the fact that you have an issue here, and to know that therefore we need to be monitoring how the system is performing when we are looking at deployment, and we need to have ways of correcting for when errors occur, ways for people who are being impacted by the system to be able to flag that they think this is actually not the right kind of outcome to happen, and basically to be a bit humble and say, you know, my system seems to work okay, but I know that I don't have enough data on this particular group, so I'm not going to claim that my system is 98% correct if I know that, well, that's because 98% of the data it was this one group, and this other group, those 2%, I'm really, really bad at those.
Fair enough, yeah. So next question, regarding the reoffending predictions, why is it mathematically impossible to make an AI system that is unbiased in all the different metrics, such as accuracy, false positives, and false negatives?
Well, this is linked to the fact that the underlying probability of, or the underlying cases that have been identified of people in the different categories, in this case, racial categories, of reoffending isn't actually the same. And so if you are making, and is hugely also the number of defendants that are being put forward of one race is much larger than of the other race, because Black people are massively more frequently arrested in the US. That if you try to create an unbiased system when it comes to false positives, it means that you will need to, in effect, more frequently tend towards making one kind of judgment for a certain party, and that will then skew you away on when it comes to the accuracy rate. It's because because you don't have a nicely balanced income input data, and you don't have nicely balanced actual real probabilities of reoffending in the underlying sort of population that you're dealing with.
Yeah, that's fair enough. Next question. The first principle is about benefiting people. How will this impact military applications of AI, and who will regulate this?
So this is an area, probably one of the first areas where the debate around the use of AI started, but it is one of the slowest moving areas. So the UN Treaty on the Use of Conventional Weapons has been trying to include AI into the kinds of conventional weapons that would be banned, such as landmines. However, as is usually the case, the countries that are the leaders in developing these kinds of technologies have shown no interest in participating in this. Their argument is that, and the US military has actually published a ethics of the use of AI guidance. Their argument is that it would be unethical towards their own population to not be allowed to use an AI system if there is a potential for an enemy side that does use an AI system, because it would hinder their ability to protect their own population. So they argue that it is actually beneficent towards their population to be able to use an AI system in automated warfare. This is an area that, I mean, from an ethical philosophy point of view, there's already the problem of distinguishing about who counts. Is it only my population, or is it the population globally? But from a realpolitik point of view, it is simply the case that those who have the capacity to use these systems to their benefit are not going to want to relinquish that, same as we've seen with nuclear weapons and other kinds of weapon systems, unfortunately.
Yep, definitely agree with you, being unfortunate there. Is there any regulation that can prevent AI changing society without us noticing?
So to a certain extent, the proposed AI Act in the EU includes something in this direction. It does include actually that using AI systems that would manipulate people without their noticing it is a banned use of AI systems. Obviously, you need to know that they're being used in order to be able to find the person. But that is sort of a different problem than the AI system. That's more a problem of oversight over organizations and their intentions. AI systems, the reality of AI systems is none of them are intelligent to an extent that would allow an AI to do things without a human having been the one that told it to do that thing. So if we're talking about governing the uses of AI systems, we're talking about governing organizations and people. And so really, is an AI going to be able to start manipulating people without any person knowing it? No, because it will have to be at least the organization that deployed it that will know about it. And as such, we might, in the murky world of the darknet and terrorist organizations, be facing particular actors who might want to manipulate people without their knowledge. But I guess that's what our security services are hopefully going to be doing if they're not spending too much of their time only surveilling people who don't need surveillance.
Fingers crossed. So you mentioned about the UK, EU and Singapore having moved earliest on AI policy and legislation. Are there any particular reasons why they have moved first? And are there any significant differences in all of their approaches?
So when the UK started moving on this, the UK was still part of the EU, and this was part of the general European, and that's not just EU, but sort of more the European approach to technology and to the question around what is the role of regulation in society, being one of a more pro-regulation, proactive, there is a role for government to guide the direction in which technology goes kind of approach. So that is why Europe, including the UK, has been more inclined to start that kind of a process early, especially as compared to the US, where the underlying culture is one of, let's try things out. If we have evidence of it having gone wrong, we will then start to regulate. That's more the general culture of how to deal with any new kind of technology, including AI. And in that kind of spectrum, for instance, is also the fact that Europe, including the UK, having been a leader in data privacy legislation, and the US still not really having come to an agreement on to where they want to be going with this. And data privacy legislation is somewhat linked to AI regulation because of the importance of data in feeding AI systems. And we see, for instance, that at the EU level, a lot of the thinking around how to craft AI regulation is looking to build on and learn from the GDPR, the data protection legislation. Singapore is similar in the sense that they have a tradition, a culture of being a fairly strong pro-regulation environment where the government seeks to be the guarantor of a safe space for its citizens. And so it tends to want to look at these kinds of new technologies quite early on. Singapore is also a place that tries to be a leader in technology, especially in sort of in the deployment of technology as a sort of an industry or a commerce hub. Japan and Korea, interestingly, even though they are also technology leaders, have been not quite so fast in picking up. To a certain extent, Japan often takes its signals from the US as to how to deal with a lot of kind of regulation kinds of issues. But Japan is moving actually faster than the US. Japan was actually the initiator of putting the OECD AI principles onto the agenda at the G20 meeting and getting that on there. Korea actually is a space where this question about use of AI in autonomous weapons plays largely into the discussion around AI ethics. And I was invited to a conference there around AI ethics and the need to start thinking about AI principles and ethics review process in the academic domain, because there had been a research project at one of the universities strongly linked to autonomous weapons, which had triggered a boycott on academically dealing with Korea. And so that was a trigger there. And of course, China is a universe unto itself when it comes to these kinds of regulations, but is actually moving forward as well with AI regulation. They've linked it strongly to their data privacy regulation, which recently they published a new regulation around providing much stronger data privacy, quite similar to GDPR actually, of course with the caveat that it applies to the way in which companies use data, not to the way in which government uses the data. So that's a bit different. But as part of this, they have included things such as automated decision-making on people and limitations on these kinds of things.
Thank you very much. That was a very interesting answer. Okay, so I think we are going to have to finish the Q&A there, unfortunately. Thank you very much, Ansgar, for the presentation as well as answering some of our questions. What I'm going to do now is just quickly share my screen to go through a couple of different slides. So we do have a few more upcoming events. The best way to find them will be going onto the IT East Midlands events website, which you can see the URL there. We will also post it in the chat for you. As well as this, we have a couple of other different events, such as Dyslexia and Engineering and Robot Day 2021 in Derby, which is virtual. As always, please also stay in touch on our Twitter. You can just find us by searching IET Twitter. It would also be really appreciated if you could fill in this survey. So this link will be put in the chat as well. It's essentially just getting your views as to how we can better understand what you want through these webinars. So just by answering that, it would really appreciate, and we would be able to understand a lot more how you would prefer these to go. So unless there is anything else to say, that will be the end of the webinar, I believe.